We've heard multiple different perspectives. I just want to run you through my perspective, which incidentally Cisco shares as well. So I've been with Cisco for the last 2.5 years. I've spent 12 years before that at some Microsystems, 3 years before that at digital equipment. So I've spent a lot of time in the data center. I've seen the evolution of computing, so to speak. So I'm going to talk about these 4 things. What constitutes cloud? Because it is probably the most abused word in the market today, right? So I just want to set some ground rules on what cloud computing is. Talk about the architectures that are required to support a cloud environment. Talk about our approach and how do you take it beyond the current conception of cloud. This is probably every single IT, and I'm sure every vendor will present a similar looking slide talking about complexity. But the point is, there are multiple applications. I know Dylan showed a slide with network cables all over the place of the old data centers. Trust me, our old data center in digital looked exactly like that. And so one cable moves and we don't know which application is getting touched. So there are multiple levels of complexity, multiple different applications, cross-connecting to each other to provide business functionality. So how does that translate to cloud computing, right? So key elements of cloud computing. I know someone put up the slide of Amazon Web Services, right? Self-service provisioning. You go on, you drag and drop, you put it in your basket, you shop, you pay by your credit card, you're done. Right? So it should be a simple web-based front end that is accessible to all users, but it is role-based. So depending on what you want as a service, you pay only for that service, or you get access only to that. The second, and this is one of the things that gets sort of marginalized in a cloud conversation, is standard offerings, right? I understand that no data center sphere, multiple different pieces of infrastructure required to support your particular application stack. You cannot change it. You've bought that application, that is the supported stack. So you run on that particular stack. How many people actually standardize their OS versions? How many people standardize what type of server is being bought? So is there a standardization on the Blade platform? Is there standardization on a 4 CPU RISC platform? People don't think standardization. But when it comes to cloud, you go to Amazon Web Services, you get a 1 CPU, 2 CPU, 4 CPU option. You get 1 GB, 4 GB, 8 GB options. You get 100 GB, 200 GB, 500 GB option. And it's all standard, is prepackaged. Why is that? It's because if you give a user total control, saying I can pick as many number of CPUs, as much memory, as much storage, it confuses the cloud management platform in terms of capacity planning and resourcing. So one of the things, the best way to make a cloud more efficient is to standardize offerings, right? So these are one of the things that I'm going to put down as one of the requirements. Very fast provisioning. Now this is something that we've all seen to a large extent. From the time a server is ordered, or forget order, from the time it lands to the time it is commissioned into production, it takes between 3 and 5 weeks. Right? That is a huge amount of time that you're losing when you could very quickly provision an application. Right? One of the things that cloud tries to solve, or actually does solve, is fast provisioning of resources. And the fourth part is metered usage. So how do you keep track of how much is being used? How many resources are being used? In what percentage are they being used? Are they being used gainfully? Or are you getting the right return on your investment? The next is resource pooling, and we heard this in the keynote as well. How do you pool your resources? So how do you create a database pool? How do you create an applications pool, a storage pool, a high availability pool, a dev and test non-high availability pool, and how do you dynamically allocate resources to that? So we're going to talk about that. And finally, this is again one of the things that is important. A lot of times people say, I need a 2 CPU machine to run a test for this particular application. Sure, here you go. People take that machine, they run test for 2 months, and then it's done. The testing is done, the server is still lying there, nobody has recamed it because there is nobody tracking the life cycle of that particular project. So one of the things that cloud has to address and should address and does address is the entire life cycle of a service. So let me get into, we've heard about these acronyms before, but the one thing that gets missed is every layer is a foundation for the layer above. Right? So we have to create a data center architecture that supports the cloud. Right? That is the foundation of the cloud. How do you build a data center which is flexible in terms of how your networking is configured, how your storage is configured, how your infrastructure is accessible. Building on top of that is where you add more virtualization capabilities and say we will provide infrastructure as a service. At this point in time, what are you offering? You're offering either a virtual machine or you're offering a bare metal server. Now, a bare metal server could be x86, could be RISC, could be an LPAR in an IBM machine, could be anything, right? But it is infrastructure as a service. So compute, network, storage capabilities on demand. The next layer is platform as a service. Now, the simplest way to look at platform as a service is app server as a service, web server as a service. Pre-configured, pre-set up, just launch it and you're done. Or you can look at Google Apps, right? Gmail as a service, but that actually goes into software as a service. So each of these becomes a building block for the layer above. Now, let's look at our approach, right? So we have a simple stack. We call it the Cisco Intelligent Automation for Cloud. The first layer tries to target the requirement of self-service provisioning and service catalog. So this is the layer that users will interact with. This is where you come in first, you ask for a virtual machine or a bare metal server or a database, right, pre-configured, and that portal will look into a service catalog. The service catalog is where you hold standard configurations. So now I'm addressing the first two requirements of any cloud. One being self-service interface, and second is standardization. The second layer is the orchestration engine. Now this is a complex engine that provides simplified workflows for you to do step-by-step process. So today in a data center, administrators do 10 things in a particular order for them to set up, let's say, an Oracle database. So they will upgrade the firmware if it is x86, they will install the operating system, they will put the right patches, they will plug the security holes, they will install Oracle database, they will configure it as per your standard, they will put the aura.init file, and you're up and running. Right? It's a standard set of things that everybody will have to do. The orchestration engine just takes all of those steps and translates that into machine learning. So you don't have to do it manually all the time. The orchestration engine takes care of it. Now, the third layer is where the Cisco approach differs from pretty much everybody in the market. We decided to not build management capabilities of end platforms into our stack. Right? So the best way to explain this is EMC's management software knows how best to manage the EMC store. Sun Management Center knows best how to manage the Spark platform. Right? UCS Manager knows the best way to manage a UCS chassis from Cisco. So instead of we creating a management layer, why not leverage these management capabilities that are there in these platforms? So what we did was we created an adapter framework. The adapter framework is a bridge between the cloud management platform and the end platform. We call them target systems. Right? So here I'm talking about UCS Manager as an example. VMware, Hyper-V, virtualization managers. There are storage devices that I have not mentioned, but in hardware managers, you get storage as well. Right? So the adapter framework now allows you to talk to compute, virtual resources, network, and storage, thereby opening up your cloud. Now, I want to step back. The reason I made that statement is some of it was heard in the morning session. A lot of people are trying to take the approach of saying, stick with our stack, and you will get a pre-baked private cloud up and running very quickly. That is all true, but you're bound to one platform, right? Which is rigid by shape. And no cloud has a fixed shape, ever. Right? Cloud by design grows or changes shape depending on requirements. So how can we build a cloud if it is restricted? If it says it will work only with Hyper-V or only with VMware, or only with EMC, or only with NetApp. That is not a cloud, right? So this approach allows us to open up the cloud and integrate with pretty much any entity that you have, target system that you have in your environment. In a large enterprise, just to elaborate on the adapter concept, we are talking to EMC, UCS manager, network devices, MDS, which is the SAN switch, talking to vCenter, but we are also talking to a bunch of other applications that are used by pretty much every organization out there. You have an enterprise management tool. You have a ticketing system. You have an SNMP trap capture mechanism. You have multiple applications that you're running within your enterprise, and all of these need to now be integrated into the cloud. So how would we do that? This is just a sample of the adapters that we have, right? And this is the comprehensiveness that we have built in. Let's say VMware, for example, clone a machine, create a snapshot, enter VM. All of these capabilities are inherited by the vSphere management engine, right? So we can now talk directly in native language to VMware, to UCS Manager, to EMC, right? And be able to integrate that as part of the overall cloud offering. So let's look at a simplified view of how we would build the solution, right? So the first thing is we define the standard architecture. So we work along with your IT team and your business team to say what is the best set of standard offerings that should constitute your cloud, right? Once these are defined, these are entries that you put in your service category, standardized offerings. You obviously go and make pricing for all of these. So there is license cost, server and acquisition cost, maintenance and operational cost. So all of these costs eventually go into cost for running a particular service. And we translate that into a dollar value for each service that is available in a self-service portal. So here, for example, I'm saying desktop as a service, application as a service. I can have IP telephony as a service. I can have telepresence as a service, HR as a service. So in Cisco, for example, even before I joined, when my manager put my information in, including my badge, everything was ready. My phone was configured. My email already had few emails. My email account already had few emails. Calendar schedule was already there. All of this was automated for me. So the cloud is no longer restricted to just doing infrastructure or virtual machines. We have opened it up to any standard offering that you would want as part of your cloud environment. So now that you've got self-service, there has to be a checkpoint, right? The user has gone and said, I need a 4 CPU machine. His manager has to approve because he's going to pay the bill. So as part of the approval chain, it goes to the management and says, do you approve of this? And he has the option to obviously approve or deny. Once it is approved, it will then talk to the orchestration engine for delivery of the service. So this is where it will talk to all the end network storage and compute elements and provide this information into the lifecycle management system. So how long was the virtual machine on? What are the usage characteristics of that virtual machine? Is it being used consistently? What are the capacity planning needs that you would need? All of this information is then provided into a tracking screen. This is when you monitor your cloud. So I'll put up a few more screenshots from a user perspective as well as from an administrator perspective. Now, to take this beyond, we keep hearing about something called cloud bursting, right? We built a cloud, we want to grow space, or we want to have DR, and we want to use Amazon, we want to use Terramark, we want to use NetMagic, could be anyone, right? Any cloud, and you want to use their facilities for high availability or for disaster recovery. This platform allows you to add here, saying that, do you have a public provider? And there are only 3 mentioned here, but you can configure a lot more and integrate with APIs to those standard providers, right? So now you have capability to not only have standard services deployed locally in your cloud, but you can now burst into somebody else's cloud as well. How much detail do we get into? Well, this is the kind of detail that we get into in terms of creating an org chart. So when there are approvals, let's say you have created a small, medium, large service, right? Or silver, gold, platinum service, depending on SLA. Platinum being complete high availability, dual redundancy of network and storage and so on. it goes into an expensive EMC box, so on and so forth. Then there is the silver offering, which is on very cheap SATA drives. It does not have high availability. It is on the cheapest hardware possible, right? These are different pools. So if you want a service to be deployed in the silver, it maybe only needs your manager's approval. If you want to deploy something on the production pool or the platinum pool, then you need senior VP approval. So this is the kind of detail where we can draw the org chart for escalation or for approvals for your particular cloud. So you can define who's the cloud admin for which, let's say, business unit, who has approval privileges, who has buying privileges or ordering privileges. So once the user has ordered, this is the kind of screen that you would get in terms of from infrastructure or platform, or do you need VDI, IP telephony kind of services? What current usage of services do you have? What is your lease period? Would you like to extend that lease, which will again trigger another notification to your manager saying, do you approve? Right? You can increase your quota, you can configure or change the kind of services that you're using. It's a single view of all the services that you have subscribed from the cloud. Similar view is for the administrator, but this time in terms of depth. How are the pools being used? So gold is being used more than every other, which makes sense. People don't always use the highest end or the lowest end, they go for something in the middle, right? So gold pool is being used, we are running out of storage, we need to add more. This helps in capacity. How many templates do you have? What are the kind of usages? So if there are templates that are not being used, how can you chunk it? If new templates are required or there is demand for new ones, where do you create them? How do you manage users? How do you assign roles? So it is a single view of your cloud and the usage characteristics. Right? Another view is from an outages perspective. Are there any triggers that have come up from the storage platform, from the virtualization interface, from your server farm, whatever. And again, talking about specifically VM monitoring, but you can create applets or portlets rather to better enhance the view of your cloud. Needless to say, every single vendor has a slide like this. Every single one, right? We all have our implementations in all of these customers. But the more important thing for us is we have recognition from some of our partners who are also perceived as our competitors. As you noticed on one of my slides, I said we are talking to vCloud Director. It's because we are complementary, right? vCloud Director does a phenomenal job of managing VMware, but it does not manage Hyper-V. SCOM does a phenomenal job of monitoring Microsoft components, but does not do VMware or Sun or EMC, right? We integrate with all of these, and therefore we are not in competition. We collaborate with them to bring the best out of the cloud infrastructure, right? Some nice words from them. And this is where I said I want to go beyond the standard conversation of cloud, which is infrastructure as a service, storage, network, servers, virtual machines, and that's it. More often than not, that's where the cloud starts and ends, in most people's mind, right? Same framework. All I did was I changed this part, which is the cloud VDI automation pack. This comes with a bunch of adapters to talk to Citrix or VMware from a VDI perspective. If it was IP telephony, for example, this automation pack would change, and the adapters you would get would be for Cisco's call manager, right? So depending on which kind of implementation you want to do, there is a pre-packaged solution available for you. We've built these adapters for you, and we can build more if required, if you have specific requirements. So keeping the same stack in place, this is what we can achieve, right? This is the example that I gave about Cisco. You have to do a bunch of things manually, create his ID on AD or ADAP, create a badge for him, create an entry into the email system, create an entry into the file server, give him domain authentication credentials, access to a particular backend set of applications that you need. All of this would be manual to a large extent. Using our stack, one standard service saying he's a user, he's a manager, he's a VP, and a certain set of standard capabilities are by default given. depending on your profile. So now your cloud is genuinely role-based, not only in terms of approvals, but in terms of service availability as well. And you can standardize your entire environment and automate it. The biggest advantage being it is consistent. There is no, oh, I forgot to do this. There is no such thing that is going to happen. It is consistent, it is the same, and it is customizable based on your business process or your requirements. Another set of screenshots from a VDI perspective. So is he a power user? Is he a normal user, or does he just need kiosks to flash marketing language, for example? Finally, this is where I want to leave you with. We can support multiple public clouds. We are actively in conversations with, around the OpenStack discussion. We genuinely want to keep this cloud stack open so that our customers are not limited to a particular set of applications only being supported on the cloud, but have the ability to add pretty much everything in their data center into the cloud infrastructure so that it can be managed as a whole and it can be automated as a whole, and thereby lowering the cost of management, the cost of operations, and bringing consistency in every single provisioning or deprovisioning that you're trying to do. So this is my final slide. The objective is obviously lower cost, bring more predictability in your environment, and reduce your TCO. So I'm superb on time. So I want to open up this time for questions, if any. Sorry, I'll go first.
My name is Malhar. I'm from Ericsson. I want to ask how big is the solution? What is the hardware? What is the software? And the other question is for this you have shown in your last slide, public cloud and then private cloud, and then in terms of private cloud, how big organization could be who can afford your solution?
That's a fantastic question. So I'll start with question one, which is how big is the requirement to run this platform? It will run in 2 VMs in a single server. So it is very light. The reason it is very light is, like I said, the adapter framework makes it not have all the management capabilities built in, but rather talk to your environment. That is question one. Question two is the size of the organization who can afford our cloud. So we've started with customers who started with 4 blades as the first pilot for cloud. Once the adapters are in place, your workflows are configured based on your requirements, all you need to do is keep adding more and you're done. Our job is done, we've already deployed it. So that was the second question. The third question was the complexity of the software. Or rather, how expensive it can be. Now, how expensive are 2 components. One is the cost of the software, and the way we license our product is based on the number of target systems. So let's say you want to start with 4 blades. Irrespective of how many VMs you want to run on it, it's 4 licenses. You grow to 10 blades, 6 additional licenses. And that's all, right? We don't charge on per VM or what application, what kind of server, we don't. There is a site license option that is available, which is renewable annually, but it is recommended for people who go 100 blades and beyond, because that is where you get the true benefit. The second benefit of the site license is that at any point in time, at the end of the contract, let's say it's a 3-year contract, and you want to end that contract, all of the licenses that you have, all of the target systems become perpetual licenses. Right? So it is an unlimited use license, let's say for 3 years. You've deployed it for 150 servers. For 150 target servers, it is a perpetual license.